3 months ago, the University of Michigan Center for Entrepreneurship awarded a biomedical engineering team a grant to pursue their idea for a healthcare solution. The result is currently competing in a national biomedical engineering competition, only possible due to the generosity of CFE and Michigan Engineering. The next 5 minutes will demonstrate the impact of the Solve It, Make It grant and detail our team's project, the REVI. Sudden cardiac arrest, or unexpected failure of the heart, is a major killer in the United States. 900 people die daily. Unfortunately, 3 individuals will be victims to sudden cardiac arrest before the end of this video. When functioning properly, the heart is responsible for the exchange of oxygen and carbon dioxide in the body's tissues. We breathe in oxygen, the beating of our heart circulates this oxygen through our body via the bloodstream, and it is swapped for carbon dioxide in the capillary networks. The carbon dioxide returns via the bloodstream to the lungs, where it is exhaled. During cardiac arrest, this gas exchange cannot occur, causing rapid tissue death. In fact, the heart dies 10% every minute it is not beating. Obviously, cardiac function needs to be restored promptly. Cardiopulmonary resuscitation, commonly known as CPR, is a life-saving technique which simulates the heart's function by having a rescuer push on a victim's chest. Unfortunately, CPR only results in survival rates as low as 10%. We believe this dismal survival rate is due to improper administration of CPR. This is where our team went to work. Our solution is the REVI, a real-time CPR feedback device based on victim physiology. As a rescuer is performing CPR with ventilation, carbon dioxide is being forced out of the lungs by the chest compressions. The REVI monitors this end-tidal carbon dioxide to make recommendations to the rescuer on how to best alter their CPR technique. Via both a screen color change and a text display, the REVI instructs the rescuer to push harder, continue at the same force, or stop and check for a pulse. In addition, the REVI emits a 110 beats per minute tone to align compression rate with American Heart Association guidelines. The internal components of the REVI 2.0 are on the right side of the screen, featuring the following improvements since our application for the CFE grant. An Arduino Mega to allow for simultaneous control of the REVI's components. A new vacuum pump for faster gas analysis. An upgraded carbon dioxide monitor, and a speaker to emit the rate-setting tone. Most excitingly, the grant allowed us to do verification and validation testing. We tested accuracy of the carbon dioxide sensors, ability of our device to influence rescuer actions, ease of operation, setup time, and effect on rescuer compression rate. We are thrilled to share our most exciting results regarding rescuer response to our device's recommendations. We asked 53 users to try our device, using a rescue dummy and an artificial chest we created to monitor compression force. This video demonstrates our user testing arrangement. Our test user is performing CPR on the artificial chest based on the REVI's display. Regardless of the user's compression force, the REVI displayed the same sequence of feedback: a welcome screen, push harder, good work, push harder, and stop to check for a pulse. This image is a graph of a single user's compression force history. Each green dot is a single compression. It is clear that when the REVI instructs the user to push harder, they do in fact push harder on the chest. When good work is displayed, this user subconsciously decreased their compression force. The results of this preliminary test are very exciting. 70% of our 53 users increased their force after the first push harder recommendation, and 66% increased their force after the second push harder recommendation. We believe this to be the first dataset indicating that providing real-time CPR feedback can improve CPR quality. Beyond our validation testing, our team was able to plan for the future of this venture. We have created a preliminary pricing and distribution model, as well as performed preliminary analyses of the reimbursement and regulatory landscape. After meeting with the Law Clinic, we will be promptly filing a provisional patent for our device. Future conversations are planned with the Red Cross to learn about implementation into CPR training programs, as well as researchers in emergency medicine for potential collaborations. We are hopeful that our user feedback data will be deemed worthy of publication in order to provide support for development of this project. Team Revival, the developers of the REVI, are immensely grateful for the support of the Center for Entrepreneurship, in the Department of Biomedical Engineering. Without this support, our solution to a daunting medical issue would not have been possible.